All right. If we want to get a grasp on the evolution of vertebrate diversity, one way to think about this is to ask ourselves the question, what exactly is a fish? And I think, of course, we all have the idea that a fish is a vertebrate animal with a backbone that swims through the water. But evolutionarily, in terms of the relationships among the different vertebrate groups, what do we mean, or do we mean anything by the term fish? So we can take the origin of vertebrates or chordates in general back to the Cambrian explosion, and we have quite a diversity in the early Paleozoic of marine chordate animals that we're not going to try and deal with here. There's even controversy as to whether these had jaws or didn't have jaws, how much bone they had, but in general they probably did have bone. Some of them might have had something like jaws. But what we see among the modern diversity of vertebrates is an outgroup or a primitive kind of group to relate everybody else to that includes the lamprey and the hagfish. Now, these are rather unusual kinds of fish-like critters. They do not have much bones. They do have little cartilage pieces along the segments of their body. They do not have jaws, and they're highly modified mostly as parasites in the head end of the body. So that's kind of our more primitive type of vertebrate outgroup, the lamprey and hagfish. As we move along, we get the evolution of sharks and rays, which have a full cartilage skeleton on one branch, with a pretty decent modern representation and quite a diversity. Not such a diversity. They're very typical body forms and full cartilaginous skeletons and rather typical kinds of movements and a small diversity within that group. And then we get all of the other vertebrates which do have a bony skeleton. And interestingly, have lungs and breathe air compared to the other previous, probably all of the fossil groups, as well as the lamprey, hagfish, and sharks and rays. Okay, so we've got this jawed group that includes cartilaginous sharks and rays with gills, getting all their oxygen from the water, and the group with full bony skeletons, principally getting oxygen from the air using lungs. Now, this group includes a lot of different critters that we would consider to be fish. And the best way to understand it is to split it up into two distinct groups based mostly on what the limbs look like. We have the Sarcopterygians, which means lobe-finned group, that includes ourselves and all of land vertebrates and have limbs or fins coming off, but have bony elements with kind of fleshy lobe-like pads, whether it's an actual limb in a land vertebrate or these lobe-type fins in our closest fish-like relatives. And then we have the other major group over here branching off that we call the Actinopterygians, which includes the ray-finned fishes. These are all critters that we would think of as fish, and they instead have fins that have thin bony spikes forming the fin and really no fleshy pads, but just extensions of skin between those thin bony spikes. Within the Sarcopterygians, we have a couple of fish, interesting, one very, what's sometimes called one of these living fossils, the coelacanth, only discovered in the last century, thought to have been extinct. There's quite a diversity in the fossil record dating back to the Devonian, but there are some deep sea coelacanths that have been brought up by fisher people, and it was quite a surprise to find them. And then the lungfish. The relationship among the coelacanth, the lungfish, and all of the rest of the Sarcopterygians, which would be all of the land vertebrates, reptiles, amphibians, birds, and mammals, or what we might call tetrapods or land vertebrates, is up for grabs as to who's most closely related to whom. And all of these groups would primitively have lungs, would have those lobe fins, and are each other's closest relatives based on many, many different characteristics compared to the Actinopterygians or the ray-finned fishes. Here we have some primitive groups, the bikers, nothing to do with people riding on motorcycles, that's B-I-C-H-I-R-S, the bikers or beakers, the sturgeons, and the gars and bone fins. Again, some disagreement over how they're all related to each other. And then what we most commonly might think of when we typically think of a fish, all of the teleost fish. This includes things that we all commonly know: tuna, salmon, goldfish, reef fish, cichlid fish, most of the fish that most but not all of the fish that you might see in an aquarium store or that you might eat. And what's interesting is this is the group that has lost the lungs, or the lungs have been converted into a swim bladder. Please note that in the beakers, spikers, sturgeons, and gars and bowfins, we do have lungs, and they do come to the surface to breathe air for the most part. Whereas in this group, lungs are lost or have been converted into a swim bladder. So now when we look across these various groups of vertebrates, we can see we have something we call fish, an eel-like parasitic fish in a lamprey or a hagfish. We think of sharks and rays as fish, and we certainly would think of the coelacanth and the lungfish as fish. And yet, right from within this group, we have all of the land vertebrates, which we definitely do not think of as fish. On the other hand, the larger group of actinobranchian or ray fin fish, including these primitive biker sturgeons and bowfins that do have lungs but live fully in the water, along with the teleost fish that have typically a swim bladder, all we would consider also to be fish groups. If we look at the overall diversity, where we see the greatest and highest diversity would be principally in the teleost fish, with some tens of thousands of species, and then also among the land vertebrates, where we see quite a diversity of different groups, with, again, in a totality, some 10,000 plus species. So, again, well, we come back to the question of what a fish is. Well, it's certainly not one good evolutionary or monophyletic evolutionary group. We can understand it as being a vertebrate animal that swims through the water. And then when we take a look, we can see that we have some nice outgroups, the lampreys and hagfish for all vertebrates, the sharks and rays, the cartilaginous fish, the jawed fish, the outgroup to all the rest of the sarcopterygians and actinopterygians. And then we have these two main groups, one which includes all of the land vertebrates, the lobe-finned sarcopterygians, and one which includes the great diversity of bony teleost fish, the ray-finned actinopterygians. That's a way of understanding the evolution of vertebrate diversity by asking ourselves the question, what is a fish?